Hi, I'm Tim Howland from Johnson Outdoors, Minn Kota. In this video, we will show the disassembly reassembly procedure for a 4-inch diameter motor unit. We currently have two 4-inch diameter motors in our product line, an 80-pound thrust 24-volt model and a 101-pound thrust 36-volt model. The disassembly reassembly procedure is the same for both. We'll use this Fortrex 80 model as a representative example of a 4-inch diameter motor that we will disassemble and reassemble. We'll start by removing the prop. Using a 9/16 open end wrench, we'll remove the nylock nut, followed by the washer, the prop, and the drive pin. To make things a little easier for disassembly, I'm going to block this motor up. Right now, when it's in the retracted position like this, or the stowed position, there's a lot of downward pressure due to the fiberglass shaft holding this motor down firmly against the motor rest. So when we disassemble it, we'll want that to be up off the motor rest a little bit. So we'll just kind of put these two wooden blocks into place. So now the motor is up and off of the motor rest assembly. We'll start by removing the two motor through bolts using our 5/16 nut driver. There are two O-rings on each through bolt, so we want to make sure that we get those along when we remove those two through bolt assemblies. And we will want to replace those when we reassemble the motor. With the two through bolts removed, the front end bell assembly, because this motor is not a universal sonar model, the front end bell assembly can be simply pulled off and removed from the motor housing. Next, we will pull the brush end housing out, and then we can pull the armature out the opposite end. And it will require a considerable amount of effort to pull that armature out of the center section here. We have two magnets that are, of course, bonded in, epoxied in place into the steel center section. So we have quite a bit of pull, magnetic pull, when we try to pull that armature out of that center section assembly. We're going to replace the brushes here at this point, and so what we will do is remove the brush springs, or actually release them from the back side of the brush, pull the brush out the back side of the brush holder, and these brushes are simply held in place with a quick disconnect terminal, where they're attached to a male terminal on the brush plate assembly itself. So again, we'll do the same thing with the other brush. Release the spring from the back side, and the brush itself can be removed out the back side of the brush holder. We'll take our two new brushes and install them in the same manner as the ones that we just removed, and plug the brush in to the male terminal. This one for the red brush lead. Now what I'm going to do here to make things a little easier for reassembly, I'm going to position this brush spring down below the brush, because I want the brushes to stay back a ways in the brush holder, so that when I slip the armature back into place, those brushes are not going to interfere with the commutator. So we need to have those brushes kind of back out of the way when I slide that armature back into position. And we'll install the other brush. Again, we'll position this other brush spring back onto the back side of the brush, and then actually kind of drop it down below the brush so that it's not actually applying pressure to the back side of the brush at this point. If we were replacing the prop shaft seals, there are two seals that are located down in this seal bore. And if we were replacing them at this point, we would go in with a screwdriver and actually pry those seals out. And then when we reinstall them or replace them, we would want to grease the seal bore, install the first seal, again with the cup side out toward the water, and we would seat that seal all the way to the bottom of the seal bore. Again, apply some additional grease to the seal bore, and then seat the second seal all the way down on top of the first seal that was installed. At this time, we would also want to replace the O-ring. So we'll just simply slip the new O-ring over the housing and into place. We'll also want to make sure that when we reassemble this, in the front end bell assembly of these 4-inch diameter motors, we have two Belleville washers. The Belleville washers are a crowned washer, and they're installed so that the crowns are facing one another. And what it does is to provide a little cushion for our ball bearing that's on the end of the armature shaft itself. Call your attention to that ball bearing here real quickly. It is a sealed ball bearing. It has a dust seal on one side, oil seal on the other. A good way to test that bearing to see if it is a good or bad bearing is simply to grab the outer race of the bearing and holding it in this manner, give the armature a little spin. It should spin freely. There should be no catching and no rough spots that you feel as the armature rotates like this. Also would call your attention to this 4-inch diameter motor armature. It is an armature that we balance. We actually spin balance that. And that's what the blue compound that you see here at this point and also here is a balancing compound. We have a fixture that actually electronically balances or points out where the balancing compound needs to be placed, and then the operator actually applies that by hand and then spins it up again and observes to make sure that the armature is properly balanced. The other thing that I'll call your attention to on these large diameter motors like this, we use a process that actually epoxies all of the wires tightly to one another so that they cannot vibrate or work against each other and create a bare spot. And it also provides better heat dissipation for the armature itself. You don't have any air spaces left between those armature windings, and so it's a very critical step for these large diameter motors that are the higher thrust and higher voltage, being that this is a 24 volt model. The 36 volt model, the armature would simply be about an inch or so longer, and the motor assembly would also be a little bit longer as well, of course, but internally they would be identical. Just to make sure that this armature is good, we'll use our VOM set to check continuity, and we'll check this armature to make sure that we don't have any dead spots on the comm and that we don't have any shorts in the armature winding to the stack. So we can test right there. We can hear that we've got an audible tone, but what we should find here is that as we go from one comm section to the other, all the way around, that we should have continuity from every comm section to all of the other comm sections. This test's okay. So now let's check to make sure that we don't have continuity from the armature commutator to the shaft itself. No continuity there. Okay, with the new O-rings installed here, we can kind of line things up and we can position things for a little reassembly. So first of all, what we'll want to do is make sure that the washer that I removed from the end of the armature shaft here is back in place. First of all, the steel washer up against the E-ring, and then the nylotron washer, which will end up running against the bushing that's up here in the brush end housing assembly. So we will kind of line things up here while I come in from the opposite side, slip this armature back into place here in the center section. Line up this plain end housing, because when I let go of this armature shaft will come right through this plain end housing assembly. Again, you notice the magnetic pull there. When I released that, it actually jumped right into place. But now I need to get back in here and release the brush springs. The brushes, of course, have to be firmly held onto the comm in order to complete the circuit to allow the motor to run. Drop those springs back into place. They are now in the groove that's provided in the back side of the brush. When we reassemble things, we want to make sure that the skeg on the bottom side of that brush plate assembly is parallel to this shaft. Now the front end bell assembly will have a small index mark that we will want to orient towards the bottom side of the motor. And you can see it right here at this point. Whenever we open up a lower unit, we would automatically replace the O-rings, and in particular, the through-bolt O-rings. We'll slip the two new O-rings in place, and at this point, it's a good idea to apply a small amount of grease on the surfaces of that O-ring so that when we tighten these through bolts back in place, that the O-rings themselves are not going to be damaged or shredded or torn as we torque those bolts back down. When we install the through bolt, we'll need to kind of feel our way into the threaded pocket. I can give it a couple of turns here with my fingers just to make sure that it's started. And then using the 5/16 nut driver, we'll want to tighten this down from side to side, pulling up the front end bell assembly, again making sure that the skeg is parallel to the shaft when it's in this position, that the little indicating mark here on the front end bell assembly is toward the bottom side, and we can continue to tighten down those through bolts. Okay, we can install the prop pin, the prop washer, and prop nut. Now, had this motor been a universal sonar model, we would not have been able to separate this front end bell assembly from the motor housing because the transducer cable comes down, runs between the magnets, over the top of a little small shield, and then attaches to the transducer that is located in this front end bell assembly. That being said, the motor disassembly reassembly procedure is very similar, much the same for a universal sonar 2 model and a non-universal sonar motor such as this one.